Hello, guys. Let's talk about the artificial space time curvature machine. And certainly, we stand again in front of the machine. I mean, it's an imaginal concept, basically. And what it has a core, its core glows, it has a ring, it has a very glowing ring. And I tell you that this machine does one thing. It has a tendency to do one thing, and that one thing changes the whole argument. It changes everything. Say, for example, what it does, it controls how space time bends. This is an imaginal argument, and we want to talk about this argument. We want to talk about the machine that has a tendency to moderate space-time curvature. Now, if we think about this machine first, it must have a core, and its core has to be filled with energy. I may call it an energy core. This energy core is the source of everything. Now, what am I trying to tell you here is that it has a key principle, the core, this imaginal core. And what is that key principle? The key principle is that this machine can convert, mass can be converted into tremendous amount of energy. And we have an argument. I mean, if even if a tiny amount of mass is taken, this tiny amount of mass gives tremendous amount of energy. Now, if I take a simple example, say for example, we have a mass of 1 kilogram, and this 1 kilogram can be converted into tremendous energy using the formula E equals mc squared. Now, to bend space time significantly, what we need tremendous energy. We need huge energy. So this is the one point of this machine. The other part is the curvature generator ring. This imaginal machine must have a ring that generates this curvature. And these rings, what they do basically is they take energy from the core. They take energy from the core and focus this energy into the region of space. So this imaginal machine has a core, it has rings. So the result is space bends, space stretches, or it compresses. Now you think about it. You are not pushing the objects. What you're doing basically is you are changing the stage on which motion happens. This is the argument. And we can think about this core. It has to have an exotic matter chamber. And it's hypothetical. What it does, it stores the hypothetical negative energy density, because you cannot bend space and time without these negative energy density, and these negative energy densities are required. They are necessary for warping bubbles. They are essential for developing the wormholes. And Without without it, only you can develop very, very weak curvature. Only weak curvature is possible hypothetically. And it must have another part, whom I call as stabilization coils. And these stabilization coils prevent prevent the runway collapse. And what they do basically is they keep curvature, the space-time curvature, they keep it balanced, they keep it stable. So if you don't have these things, otherwise you risk you basically risk forming something like like a black hole unintentionally. So you need those coils. And then there is another part we can think about is the control. It has to have a control system. And we may call this control system as the brain of the machine. And the core law that are involved in this framework. So what am I trying to say here is that you have a machine, a hypothetical machine, where the energy determines the curvature. And what you do is you control energy. And when you control the energy, you can control space-time curvature. And in moving ahead of this problem, what we would like to do is we would like to go with some deep, simplistic stories to realize this machine, a machine capable of transforming space-time curvature. And now we move from a hypothetical structure to an experience. Now, I will choose the first example as walking on the Mars. Now, suppose a person has to walk on the Mars, but he wants to walk on Mars like Earth. And let us assume that we land on Mars and we take a step, we take a shot, we take a step and feel like unstable because we are experiencing the gravity of Earth. So the problem is, what's the problem? The gravity, the acceleration gravity on the Mars is 3.7 meter per second square. And the acceleration due to gravity on Earth is 9.8 meter per second square. So what's going to happen? Your body muscles weaken and there will be the bone loss. And And what we do is we activate the artificial space time machine. We activate this machine. What machine does? The machine it bends the space time beneath your feet, beneath our feet. So, what actually happens? How can we illustrate this thing? What's basically happening here is that gravity, first of all, the gravity is not a force. Gravity is not a force in the framework of general theory of relativity. It's a curved space-time guiding the motion of the celestial objects in the observable universe, in the solar system, in the Milky Way. And what actually machine does? The machine increases the local curvature. It enhances the local curvature. So this enhancement of the local curvature, it results in what's happening is your path through space-time curves more sharply downwards. And what happens? You feel normal. You will feel normal as if you are on the planet Earth. You will feel the normal weight, the weight that you feel on the planet Earth. If we think about the objects, they fall at Earth like acceleration, the acceleration based on the acceleration due to gravity of Earth. And liquids, they behave normally. And human biology, the biological network, uh, is going to stabilize on the in vicinity of you on the planet Mars by using this artificial imaginable machine. We did not basically increase the mass of the Mars. That's not the argument here. We're not enhancing the mass of the Mars so that its gravity equals the gravity of Earth. What we are doing is we're using the mechanical force, and that force does that. What we did modify the space time geometry locally in the local environment of this map. Let's go with another example. Let's take another approach. Uh, and this approach is like taking a travel to a star. And we aim for a star which is 4 light years, say, for example, 4 light years away from us. And if we talk about the speed of light, what speed of light does? Speed of light is basically a limit. There's a limit to the speed of light. You cannot move in space. You cannot move through the space faster than that of the speed of light. And you have a star, and this star is 4 light years away from you. And what the machine does, what this artificial machine is capable of doing. Now, instead of moving you fast in the space, what it does, it changes the space itself. What am I trying to say here is it compresses space in front of you and it expands space behind you. It compresses space in front of you and it expands the space behind you. And what it physically means, what does it mean physically? You sit still inside the same bubble, inside normal physics. And outside, the bubble is the machine in which you are being. Outside, the space time is moving. You're not making light to move, you're making the space time curvature to move. The distance between start and the destination, the star, it shrinks, it goes down, and it increases from behind. So the result from outside, it looks exotic, and from inside there is no extreme acceleration. You are in that bubble. There is no time dilation, damage. There's no dilation in time. You're simply capable of shrinking the space time in front of you and space behind you. And this travel will certainly shorten. This travel will be very short. Now let's take the deep insight in this argument. You are not basically breaking relativity. You're not breaking relativity. You are basically using relativity, the laws of relativity. You're using it in a very, very cleveristic way. And what you're doing, you're moving space. You're not moving yourself. So that makes your journey possible. And let's go with another important hypothetical story of the story of wormholes. And wormhole is a shortcut. We hypothetically we think about wormholes as shortcut through relativity. What we do is we build two machines. Say, for example, the machines that we are talking about, one on Earth, the artificial machine, and the one near to a nearby star. Now, what happens? What these two machines do, they bend space time. They bend space time so strongly that the two distant points connect directly. They are able to connect directly. So, what can be the visual understanding of this argument? How we can understand this argument, and what can be the visual way of realizing this kind of argument? If you imagine a sheet, say you have a plain sheet, and on that plain sheet, 2 points. They are very far from each other. They are very apart from each other. Now fold this sheet. Now, if you fold this sheet, poke a hole. That hole is a wormhole. Now, what it means, what physical meaning it can have. Space is space is not flat, and it can be connected in non-trivial ways. Of course, it's challenging. Uh, it's a very huge challenge because wormholes collapse. They collapse instantly, and for that, what they need these negative energies to keep open. So the result of the argument, what you do is uh, you step in, and there is no travel time, and there is no intermediate distance. As you step in, it's very short. So if we try to take on the deep insight in this argument, the distance becomes irrelevant. It doesn't seem to have any relevance because you're capable of modulating the space time. And what the truth here is that the geometry defines reality. It doesn't define the separation. The geometry has everything to do with that. Now, we can go with another argument, like the argument of controlling time. What we do is we create strong curvature region using this machine. And you do this using the principles of physics, using the laws of physics. Now, what happens is that time depends on gravity. So, if time depends on gravity, what does that mean? You can have strong curvature, and if you have a strong curvature, then what happens to the time? The time slows down. And if the curvature is weak, for weak curvature, time will speed up, time will go faster. So, what we do? We stay this machine. I call it ASTC, Artificial Space Time Curvature Machine. What it does, it creates a deep curvature wall. A deep curvature wall. And what happens then? What's the result? Your clock runs slower. And outside world runs faster. See, it's so beautiful, at least hypothetically. So, what am I trying to tell here is I will take an example. Like you experience one year and Earth experiences 50 years. Why? Why is it so? Why you will experience 1 year? This is because time is part of space time. So, changing geometry, if you change the geometry, it changes time, it changes the flow of time. This is what it means. This way we can understand it, we can realize it. And what we say time is not an absolute physical quantity. Time is relativistic. And this machine can do the miles. It's shaped by the space-time structure. And and we can take another example, saying saving this planet Earth from asteroids. The asteroids that are coming. An asteroid approaches Earth and and it has a normal approach. And the normal approach could be that you can use rockets uh, and then you apply the force. But you have another option, that is ASTC approach. What we can do is we can simply bend space time in front of the asteroid. Now, if you bend space time in front of the asteroid, what's going to happen? The asteroid follows a path, a path in geodisk. The asteroid will follow that geodisk path. What we did, we have changed the path. We change that path by changing the space time curvature around that asteroid. So, what is the result? The result is the asteroid naturally curves. It curves away, and there is no collision. The asteroid is not going to hit the planet Earth. No collisions. It's a beautiful argument. Now, deep inside this argument is what we do basically is we did not push the asteroid. We did not hit it by a rocket, by a bomb. What we did basically is we changed the rules of motion itself for the asteroid. So this is how we can imagine that what this machine is capable of doing. And obviously, artificial gravity can generate artificial gravity in a spacecraft. And suppose you're in a spaceship, and inside a spaceship, uh, normally there is weightlessness. We see we see the astronauts in those probes. They hang on because there is no gravity. The resultant gravity is zero. And for that, we have the uh, traditional solution is rotating spacecraft. But if we think in terms of this ASTC solution, this machine creates curvature, and it creates curvature downwards. Now, if it creates curvature downwards, what should we expect? What's going to happen? What's going to happen there is your natural path curves towards the floor. And what you feel weight in a satellite, you feel weight in Artemis 2. And what's the result? You're not rotating the spaceship. No rotation is needed for generating the weight. You have a very feeble and stable environment, not inside the machine, and you're experiencing Earth-like living conditions in this spacecraft. And if I take this argument deep down, try to understand it in a very simplistic way, in a very simplistic fashion, what does it mean is that gravity basically becomes an engineered property, a property that can be modulated. It's not the natural limitation. You can play with this machine on gravity. Now let's go back to that important hypothetical values. And what am I trying to say is that let's ground everything, and uh, we know about the speed of light, the fastest, and what you have energy from 1 kilogram. Okay, this you can convert using E equals mc square, and that will lead you to nearly 9 times 10 to the power of 9 joules of energy from that 1 kilogram of mass. And if we think about the scale of Jupiter's mass, and and there, there is warp wormhole energy, and you can you can think of those tremendous energies that can be developed from the matter using simply E equals mc square. Now, to take on this argument on the final understanding, it is all like a story, it's all like a fairy tale that I was trying to demonstrate. And we step back from the machine, has come out of that machine. I ask you a simple question. I ask you a simple arguable question. What did we really build? In reality, what was it that we had built? We had not built a vehicle. We had not built, I may say, a weapon, not just a tool. What we did basically is, hypothetically, we built a way to control gravity, to manipulate gravity. And controlling and manipulating gravity means you have the power of reshaping the space. You have the power of altering the time